Hello, my name is Elena. I am a third-year PhD student at the University of Warwick, Computer Science Department. I'm supervised by Dr. Maria Likatan. So my work is in the area of natural language processing, and specifically my research focuses on rumor stance and veracity classification. So when I talk about rumors, I mean I'm working on rumors that are spreading on social media, well, namely on Twitter. And by rumor, I mean some unverified story that is potentially related to some event and is being spread widely on social media. Well, it's not a secret to anybody that nowadays rumors and false information can reach a very wide audience in a very short time. And like the usual manual approach taken by journalists is no longer scalable to this amount of misinformation. So basically, we are hoping to create an automated system that will assist journalists and decision makers, anybody to verify the information they're given. So rumor verification is a very complex process, and it can be broken into a number of steps. So on the slide, you can see like a proposed pipeline on how to approach rumor verification. So it starts with rumor detection. So we need to see that indeed something is an unverified claim and is worth checking. So it's not an opinion piece or a chat. After we detected a rumor, we want to collect a number of sources that are talking about the same rumor story. As we collected those, we identify the stance of the sources towards the truthfulness of the rumor. They can be supporting, like believing it, or they can say, or they can deny it, or question, or comment on it. And the final step is actually verifying a rumor to say whether we can determine if it's true or false, or it remains unverified. So here you can see an example of the conversation. So here it's a false rumor that Michael SCM have Ebola. Some people say, yes, it's true. Some people think it's a conspiracy. And unfortunately, majority of people don't care. They just comment without, addressing whether it's true or false. So one thing in my research what we care about is that conversations actually have structure, that they can be, for example, broken down into branches that go from source tweet into the responses. And so our first step that we were looking at was stance classification, and we were looking at the model that is able to model time series such as a linear branch of tweets. So that was a recurrent neural network that's called LSTM that was taking a tweet at a time and giving us a label for a tweet, so we could see which of the responses were expressing which type of stance. So as we created that model, we took that as a base model, and we designed another model that tackles several tasks from verification pipeline I have shown you before, but jointly. Looking at that, we have shown that actually training together a veracity classification model together with two auxiliary models for stance classification and rumor detection is indeed helping us predict the final veracity of the rumor. Although there is, of course, a lot more work to do in this area, and one of the next steps is to look into the whole tree of the conversation. Yeah, thank you. This is me and my supervisor.